Hi all. Today we are going to discuss about computer paradigms and its types. What is computing? Computing is the use of computers to process data, perform calculations and execute tasks. It includes areas like programming, data analysis and software development. Properties of computing system. Computing systems are reliable, scalable and available. Reliability refers to the ability of a computer system to consistently perform its intended functions without failure. Scalable is the property of a computing system that allows it to handle an increasing amount of work or its potential to accommodate growth. Availability refers to the extent to which a computing system is operational and accessible when needed. Types of computer paradigms. There are mainly five types of computer paradigms. They are distributed computing, grid computing, cluster computing, utility computing, and cloud computing. Let's look onto it. Distributed computing. It is a field of computer science that involves multiple computers working together to solve a problem or perform a task. Instead of a single computer handling all the computation, the work is distributed across several machines, often referred to as nodes or servers. These machines communicate and coordinate with each other over a network, sharing data and processing power. Advantages of distributed computing. They are scalable, fault tolerance, resource sharing, parallel processing, cost efficiency. These are the advantages of distributed computing. Complexity, security risk, latency, fault detection. These are the disadvantages of distributed computing. Applications of distributed computing. These distributed computing systems are used in areas of cloud computing, big data analytics, scientific research, CDNS, and blockchain. These all are about distributed computing. Second one is grid computing. It's a type of distributed computing where a network of geographically dispersed heterogeneous computers work together to solve complex problems. It involves pooling resources like processing power and storage from multiple organizations and locations, allowing them to share and use each other's capabilities to tackle large scale tasks efficiently. Grid computing is often used for scientific research, large scale simulations, and data analysis. Advantages of grid computing: resource utilization, scalability, cost efficiency, collaboration. These are the advantages of grid computing. Disadvantages of grid computing: complexity, security concerns, performance overheads, heterogeneity, network dependence. These are the disadvantages of grid computing. Uses cases of grid computing. Grid computing is used in the fields of scientific research, healthcare, engineering, financial services, academic collaborations, etc. Third one is cluster computing. It involves connecting multiple computers or nodes to work together as a single unified system. These nodes collaborate to perform tasks more efficiently than a single uh, machine could. Clusters are used to increase computing power, improve reliability, and enhance performance for tasks uh, such as large scale data processing, high performance computing, and web hosting. They are often configured to handle parallel processing, distribute workloads, and provide redundancy in case of node failures. Advantages of cluster computing: increased performance, scalability, high availability, and cost efficiency are the advantages of cluster computing. Disadvantages of cluster computing are complexity, scalability issues, and single point of failure. There are three types of cluster computing. There are load balancing clusters, high availability clusters, and high performance computing clusters. User cases of cluster computing. Cluster computing is used in the fields of scientific research, financial services, web hosting, media rendering, big data processing. Fourth one is utility computing. It's a model where computing resources such as processing power, storage, and applications are provided as a metered service, similar to utilities like electricity or water. This approach allows users to pay only for the resources they use, rather than investing in and maintaining their own infrastructure. It's often associated with cloud computing, where services are delivered over the internet and can scale based on demand. Advantages of utility computing: cost savings, scalability, and reduced capital expenditure are the main advantages of utility computing. Disadvantages of utility computing: security concerns, dependency on service providers, uh, potential for unexpected costs, and limited control. These are the disadvantages of utility computing. Main use cases of utility computing are cloud services, data backup and recovery, and scalable web hosting. Uh, Big data processing and development and testing are also applications of utility computing. Our last computing paradigm is cloud computing. It's a technology that allows users to access and use computing resources like servers, storage, databases, network, software, and analytics over the internet, often on a pay as you go basis. Instead of owning and maintaining physical hardware, users can leverage cloud services provided by vendors which offer scalability, flexibility, and remote access. There are different models of cloud computing, including infrastructure as a service, platform as a service, software as a service, public cloud, private cloud, and hybrid cloud. Advantages of cloud computing: scalability, accessibility, flexibility, quickly deploying and managing applications and services, disaster recovery, automatic updates. These are the main advantages of cloud computing. The main disadvantages of cloud computing are security concerns, downtime, compliance issues, latency, and vendor lock-in. Use cases of cloud computing. Main applications of cloud computing are data storage, software development, and data analytics. Customer relationship management, collaboration tools, machine learning are also main applications of cloud computing. These all are about these all are about computing paradigms. Thank you.